So my name is Brian Mawhinney, and I am the coordinator for the Renewable Energies Technician Program here at Niagara College. I've been with the college for 10 years now, and have had the pleasure of working in the Renewable Energies program for a number of those years. This program focuses on a number of different subject areas where we take a look at the use of renewable resources. And a renewable resource is simply one whose use today does not affect its availability tomorrow. And that could be electricity, that can be hydropower, that could be solar energy, that can even be forestry in some circumstances. In the Renewable Energies program, we are teaching the students about a number of key areas in the renewable energies field, such as wind turbines, solar power, geothermal, heating, ventilation, and air conditioning, and energy efficient building codes, to name a few. One of the teaching aids that we use in this program is this simple device right here. Now, many of you will likely recognize this. This is a window unit air conditioner. And we use this example to bring to light the function of this air conditioner. And first, I'm going to start by asking you a question. If you have a water pump, what does that pump move? Water. If you have an air pump, that pump moves air. Well, this device is what's called a heat pump. So most of us will recognize the function of a window unit air conditioner, in that what's happening with this unit right now, if I stand beside it, I can feel cold air on my left hand and I can feel warm air on my right hand. What this device is a heat pump. And so it is actually moving heat from this side of the unit to the outside of the unit. In a conventional residential setting, this would be used to cool down your home in the summertime. So a heat pump does that by simply taking heat from the inside of your building and rejecting it to the outside. This is a device that can be used to cool or heat an area just by simply changing the orientation. Now, this device is only meant for cooling an interior surface, but we use it as a teaching aid. And so if I simply change the direction of this heat pump, now I have heat moving from my right side to my left side. So by simply changing the orientation of this heat pump, I'm actually able to change the direction that heat travels. The only fuel source for this device, and many devices like it, is electricity. And that brings us to a number of the key study areas in the Renewable Energies program, which is generating electricity from renewable resources. This is one of our pieces of the lab equipment in the Renewable Energies program called the Alternative Energy Learning System. And this piece of equipment is used to teach students about taking renewable energy from multiple sources, storing it in one storage system, in this case a lead-acid battery, but this can be any type of battery bank, a lithium-based battery bank, etc., and then using that resource later. So right now on this demo, we have set up a solar system with a simulated sun shining on a couple of solar panels. We're able to, in the lab environment, we're able to control these parameters by turning on and off our simulated sun. They're simply halogen lamps. And those solar panels are going to produce electricity. So at the same time as those solar panels are producing electricity, I have a secondary power generation system, and this is a small DC wind turbine. Now again, this is a lab environment, so we're simulating as much as possible so that we have control over parameters. In the case of the solar system, we're simulating the sun with lamps. In the case of the wind turbine, we're simulating the wind with an electric motor. Now we have the ability to change parameters such as the available wind speed, which will have an effect on the rotor speed of a small-scale DC generator. And so when I adjust the motor speed, we'll actually see an increase in the DC charging current. This is currently connected to a low-voltage 12-volt system, which is a perfect example for small off-grid applications, and it's infinitely scalable. That is the really interesting thing about this particular trainer, is that everything we see and everything we learn on here in this trainer is infinitely scalable. This could be increased to the size of an entire house, or perhaps even a commercial building. So what I'm able to do with this system is I can power some crucial loads, such as lighting, directly from the 12-volt DC battery bank. And so that's what this is demonstrating here. If we have residential loads that we want to be satisfied by our off-grid renewable-based system, we could power them directly without having to change the DC voltage into an AC voltage and then power our loads. However, some loads will not operate on DC. For instance, your cell phone charger or your laptop power supply are designed to operate at 120 volts AC, 60 hertz. And so we have small inverters which are able to take this low voltage DC and they're able to invert using power electronics and create 120 volt AC 60 cycle electricity. And so that's what this particular light bulb is powered by. And as I mentioned, this system is infinitely scalable. We can add solar capacity, we can add storage capacity, and we can add wind and other renewable-based resources to this type of system and make it scalable to whichever size application you're looking for. As part of the Renewable Energies Technician program, students learn on a number of pieces of equipment, some of which are designed to simulate a number of the functions of utility-scale wind turbines. And that's what this piece of equipment beside me is designed for. This piece of equipment contains a piece of software called HMI, Human Machine Interface, and that allows the students the ability to interact with a simulated wind turbine in a very similar manner to the way which they would in the field. So students are able to control different parameters. Students are able to monitor different positions of solenoid valves and hydraulic pins and braking systems and all of the major components in many modern utility scale wind turbines. And they're able to do that in real time with an environment that simulates the activity of a real utility scale wind turbine. So right here, operating right now on this trainer, I have a feedback loop which is reading a simulated wind speed. It's sending that information into a turbine control unit, which is processing that information, and then in return, telling the wind turbine which direction it should face. And that's called yaw. The direction which the wind turbine will face should always be into the wind. And so if I make a simple adjustment to my simulated wind speed, what's happening is there's a device up on top of this simulated nacelle that's called an ultrasonic anemometer, and it is measuring both the wind speed and the direction. So by changing the direction that that wind is coming from, that feedback loop is processing that change in information, and the turbine controller will actually make an adjustment to the yaw position, and it will cause the nacelle to line up with the wind direction. And that's what you see happening beside me at this very moment. This is a real-time tool that students are able to use to learn on, and they can program this trainer to work in automatic mode as well as in manual mode, whereby the students are able to override and manually control certain functions of the turbine. Students in the Renewable Energies program have the opportunity to take part in a number of exciting activities as their studies progress. Some of those activities include learning how to install real solar panels on a real rooftop system and learning about all of the different tools that are involved in the process of actually setting up a rooftop solar system. Students also from time to time have the opportunity to learn about different processes such as biogas production by building their own anaerobic biodigester and producing real biogas. Thanks for coming on this virtual tour with me here at Niagara College. I very much hope in the future to see you on campus pursuing your dreams as a renewable energies technician.